Thanks everybody. We are just about good to go with the second two-panel session, so get yourself a seat. Just a reminder, you'll get another opportunity in 1 hour's time to visit the trade exhibits you haven't had a chance to visit yet. Don't forget, there are many more just outside the back door and down in the other rooms. So make sure you take everybody in. For now, though, we'll be concentrating on our next panel, and I'm delighted to welcome them all to the stage. The subject matter is biotech, biorisk, and biosecurity. And our panelists for this are Dr. Jaime, who's a lecturer in agriculture at CQ University. Please make Jaime welcome. Dr. Nancy Schellhorn is co-founder and CEO of RapidAim. And Rob Long, the director of Crown Analytical Services. And to crack the whip for this session and to fire the questions, a person very well known in this community and this cohort and indeed this event, Liz Alexander. This is, you remember, was exactly back in the other week. Something of a homecoming parade for Liz. Liz, in fact, got me involved in this event. Just after the war, and it's a great relationship. These days, she has moved on. I won't say necessarily to greener pastures, she's moved on. She's now Commercialisation Facilitator I4 Connect, the delivery partner of the Australian Government Entrepreneurs Program, and obviously works closely with businesses in central and southwest Queensland, and tech businesses nationally to bring novel products, processes, and services to market. Take it away, Liz. No videos this time, so you can start.
Yeah, no videos. Welcome everybody. Thought we might start this panel just by checking out, and I promise that I won't actually pick on you to answer, but if you would feel confident explaining what biosecurity is to a stranger, put your hand up. Okay, that's 0. Oh, we got 1. 2 or 3. Woohoo! So let's just start with a couple of explanations of what we're talking about before we even get stuck into the thick of things. So biosecurity is the management of the risk of plant and animal pests and diseases entering, emerging, establishing, or spreading. And biosecurity is relevant at the farm level, at a regional level, at a state level, and obviously at a national level. It's possibly also worth just touching on what a pest is as well, and no Kerry Hayes, no self-references. So pests include insects, mites, snails, nematodes, pathogens and diseases, weeds, anything really that has the potential to adversely affect your food fibre, ornamental crops, bees, livestock, poultry, and aquatic species. So it's the bread and butter for all farmers, and agronomists, and advisors in the room. There's 2 types of pests, and we'll talk about both of them today. Exotic pests, Emerald's had its fair share of those, so they're pests that aren't currently present in Australia, and then endemic pests that are already established, which represents, most of the weed and pests and diseases that farmers deal with on a day-to-day basis. So now that we've done the recap, does everyone think that biosecurity is directly relevant to them? Or do we not know how to put our hands up? So was it fake poll to start with? Cool. Okay. Well, let's start by talking to our panel. I'm just going to start by going left to right to start with. That's my name. Dr. Nancy Schellhorn, could you explain a little about what you do at RapidAim and how that's relevant to biosecurity?
Thank you, Liz. Is this on? Terrific. So RapidAim is digital crop surveillance and protection, and we take the guesswork out of pest management. Our first application is fruit fly. Now, fruit fly is the biggest global biosecurity barrier to trade. And in order to move fruit across state lines, certainly overseas, monitoring for fruit fly is mandatory. So when we were scientists at CSRO, we started to ask the question about where and when pests showed up, whether if growers knew, if government knew, how could that really change the way in which we either keep pests out, detect the first ones that come, or better respond and manage them. And it just so happened that we developed technology that is an early alert system for surveillance or a central piece to helping manage the pest once it's established. So at RapidAim, that's what we do, digital crop surveillance and protection.
Great. Dr. Jaime Manning, I'll just call you Jaime from now on.
Please do.
Would you like to explain a little about what you're doing and how that's relevant to biosecurity?
Yes, I'm a livestock scientist at CPU. All my research specialises around precision livestock tech, so smart tags, animal sensors, e-tags, collars, similar to Fitbit that you're wearing that's telling you that you get up and go and do 100 more steps today. And we're not just using that technology, but using that technology to address production, health, and welfare issues for a variety of different livestock species. My perspective today is going to be a little bit different to Nancy and Rob because we talk about exotic diseases for livestock and especially for technology. We're not quite there yet. So a lot of the concepts and ideas that we're talking about for livestock are still a little bit more blue sky. When we talk about endemic diseases, there's plenty of research that's still currently underway and it's slowly getting integrated into this technology to provide an early alert warning that something's going on. But for those exotic diseases, it's a little bit different. So a project that wrapped up last year that I was involved in was pretty much looking at that next generation smart tag, all the next generation national livestock identification, that RFID tag. What does the future of that technology look like? And one particular example or case that was looked at was all around FMD, foot and mouth disease, those exotic diseases, and how we could use tech for early detection of it.
Great. And Rob, so Rob's got 30 years experience, and while it didn't actually note it in the book, obviously those of you who are in the grains industry know what Rob through his work with predictability. Do you want to chat a little about how your business is relevant for biosecurity, Rob?
Sure, I suppose our angle of biosecurity is looking at plant pathology and cropping diseases. So I actually started Crown Analytical Services about 10 years ago, and so in my role as an agronomist, Maureen, our biggest, one of the greatest robbers of yield for certain cereal crops was Crown Fusarium, Sida community area. And at that stage, we started the business as a way of a detection and management of the disease. From then, and we're using predictability for the detection and management of the Protolactis thorny-eyed nematodes. Predictability became relevant for Crown only when they changed the protocols, because you're trying to measure a stubble-borne disease with a soil-borne test. So it took some research through Steve Simpendorfer and the New South Wales Department to be able to change the protocols for sampling to be able to make it relevant. So at this stage, we got more heavily involved with predictability as a disease detection and monitoring system. As of about 3 years ago, we implemented a project with CHDC to roll that out. And notice Susan Nass is here, and she was a big part of believing in what we're doing, to be able to use the same predictability technology for the detection and management of verticillium and black root rot. And last year, part of our milestone for the project was to get the genetic signature for the defoliating versus non-defoliating strains of verticil in cotton, which we achieved, and now we're just rolling that out into, certainly the first thing is a validation process, and then it will follow up with a commercial product.
So it's quite interesting here on our panel because yes, you can see that they're all involved in surveillance of some sort or pest monitoring. However, they're all working in slightly different areas. So clearly, Nancy is early commercialisation or commercialisation phase. Nancy. Jamie's in the blue sky research, and then Rob, while you're doing some new things, Crown's pretty well established, isn't it?
Yeah, sure, but there's still new concepts that we're trying to break through. Yeah, so I would still say we're at the very early end of the level of commercialisation and adoption.
Yeah. So when we're thinking about surveillance, it's also quite interesting here, and I'll seek some comment from the panel, but one of the important things about surveillance for pests and disease is that if you catch it early, hopefully you stop it from moving rapidly and spreading, and it costs a lot less. However, that's maybe not quite so true with soil disease. But let's start with Nancy. Nancy, how do you see your surveillance group assisting with that prompt and rapid assessment? Obviously, RapidAim is pretty apt.
Yes, indeed. So we became fully commercial for fruit fly surveillance and management in January of 2020. So far, our customers have rolled out over 600 sensors, it's about 180 end users, and we deliver our service of real-time fruit fly detection, and now moving into fruit fly forecast to government and also then to growers. For our government customers, there's a couple of very interesting use cases for those customers. One is north of Melbourne, the Yarra Valley. So this will be the third season. They have a grid of over 150 sensors, about 260 square kilometers. They've just increased their subscription and another 40 sensors. So they'll have almost 200 sensors over 330 square kilometers. And they're interested in detecting the first Q fly that comes into their season, into their area each season. And so for 2 seasons in a row, we've detected the first fly that comes in, and what that allows them to do, because it's real time, is a few things. One is they can respond rapidly to where the detection is. They immediately take more RapidAim devices and put them in the area to be able to identify where the pest is and where it's not, the area freedom piece. But in terms of some of the metrics and cost effectiveness, it reduces, so the way that fruit fly is done today is manual traps, right? So somebody drives around, lots of times it's government, sometimes it's agronomists, and they visit a manual trap every 7 to 14 days, and they look inside, and in areas where they don't have the pest, 99% of the time the trap is empty. So what RapidAim is doing for these communities who want to keep fruit fly out and historically haven't had fruit fly, but it's knocking on their doors, it's a 10-fold reduction in the number of times they have to visit these traps every season, but it reduces their cost today already by about 35–40%. And if they get an outbreak somewhere, it can reduce their cost by almost 70%, just because of how fast they can respond, how fast they can identify where the problem is, and how quickly they can be on top of it. They don't have to wait another 7 days or 14 days to even find out that they have a pest. So that's a real commercial example of where surveillance is being used by both the grower community and government. It's a nice co-investment model. For that one pest that is a pest that stops trade.
I'll talk to Rob next because, Rob will say this is commercially available at the moment. As you say, you're still developing more. Do you want to talk about, some of the commercial real-time sort of outcomes that you've had with growers and producers who are adopting some of these technologies?
Okay, so maybe I didn't explain it well enough before, but we're using DNA, we're using the SARI predictive beast system is using DNA to identify soil inoculum or inoculum of plant pathogens. So that's the detection system. So a couple of ways. Part of the monitoring system is we're trying to look at that on a quantification basis. So using grid samples to be able to generate heat maps of inoculant disease in fields so that growers can target specific areas with novel techniques. It might be manipulating nitrogen levels, could be manipulating water management systems, could be increasing potassium layers. So one thing that also that we use the system to do, it's almost like using to assess the validity of new products coming over the market. It's like on chip. There's a lot of products that come in that may have the valid or spurious claims about levels of control. The one thing we Don Chip said is you keep the bastards honest, and it's a little bit what we're doing. Is if there's a claim for a product that we are able to validate and quantify quantify whether that product is working or not.
So there's your first 80s reference for today. Anyone remember who Don Chip was? Sorry, Rob, I do anyway. Jaime, do you want to talk about, where do you see the first commercial impacts of this livestock identification system being used as far as, predicting disease or managing symptoms?
So obviously in our ideal situation, we want that quick identification and intervention for something that's going wrong. And where we're currently at in our system is all of the identification and response is put back on that producer. So that producer currently has to identify that something's going on in that paddock, going on with that animal, and then has to either make that call or they're saying suspect that something is happening, whether it is FMD or something else. And so that current time frame can be quite long because, well, we know our paddocks, very extensive systems, we don't see our animals quite regularly, and so how can we have that early detection and identification that something's going on in that paddock? And we currently don't have that. And that's sort of where the biggest gap and potential is for when you talk about technology, AgTech, smart tags, is being able to use that information that's coming from the device to tell us information for that individual animal. And so what is that individual animal doing? And that all comes down to the behaviour of the animal or how active it is. And so when we look at these smart tag technologies, and there's a variety of different types of tech that sits in it, we're able to use that information, those changes in that animal, to have that early detection, something's going on, early intervention, so we actually can intervene when something's happening.
Yeah, great. Okay, so I'm going to pose a couple more, general discussion points with the panel, and then I'm really keen to get Pete and you all involved and ask questions. And we'll touch on some other technologies too as we go along. Nancy, what's the biggest gap at the moment do you see in biosecurity technology?
Yeah, probably the biggest gap is it's a hard problem to solve. You're trying to detect something that is usually a very few individuals or small population of something that is entering a huge space. So one of the biggest gaps is how can we both be well prepared, and part of that well preparedness, I think, is working with a range of science and technologies to both understand entry points, but also to be doing surveillance on the ground. I think, surveillance is very much a government issue usually. It's about keeping something out. Once it's established, it becomes an industry problem. So I think there's a lot of, Australia has some of the best cutting edge technology. I think one of the biggest gaps is really believing, so it's a cultural one, that we can create global technology that absolutely, and a service around surveillance and response for biosecurity. So I think first the gap is we have to believe that we should do something and can do something today, and it's actually an industry that we could be exporting to the world, an industry that doesn't make us less competitive, it makes us more competitive because it's in everybody's interest to try to keep pests and diseases out. So that's what I think the gap is, a little bit of cultural.
So let's think big picture, Jamie, when you're thinking about, what's the biggest gap? Surely in these days of citizen science, with this sort of technology, can't we, every single farmer and every single landholder, be part of the network that prevents, exotic disease coming in or, significant pests moving across regions?
Definitely, I think everyone has a big role to play in this, but I still think tech has an even bigger part in that, because you can't monitor every single animal, and when you look at, say, foot and mouth disease, so it's a viral infection, and it causes blistering on the tongue and the hooves of animals, fever, they become a bit lethargic, they go lame. Being able to pick up some of those things right when that happens can be really challenging, even to the most experienced person, vet or emergency health officer. And so if we can use tech to start picking up some of those subtle changes in that animal before we start seeing all of these clinical signs, or before we start seeing masses of dead animals, we have an earlier time frame to work out what's happening, where is it happening, and then quickly put some control measures in place. And that's what we currently don't really have. It's that time lag. It's relying on someone to say, yes, I actually think something's going on. And then that could be several days, weeks later, where if we had tech, it could be a matter of hours, a matter of days that we know that something's happening.
So it's quite interesting too, because if you actually have a look at the number of diseases and pests that are incursions in Australia, it's the old adage, if it bleeds, it leads, is very true. There are many, many pest diseases and pests that are incursions in Australia that are being managed, but it's quite a different matter, when we have a livestock incursion. So, Rob, over to you. Where do you see the gaps are? I know when we were chatting about this earlier, and I was being a little bit flippant, but I was saying, why don't we have predictability for everything? And you said, well, it's complex.
It is complex, as Nancy indicated. It's a biological system, so and there are interactions. I still believe strongly that the disease, spatial disease, or disease is the missing spatial data layer. Jim Neal before was saying we've probably got too much data. I think here is a layer that has a material difference on outputs, but we don't know enough. We're not measuring it well. Every year in Australia, there's something like 300,000 soil tests taken for nutrition. Every year, there's 1,500 taken for disease. So there's a massive discrepancy in the importance, not the importance, but what's seen as important for nutrition versus disease. And why is that? It's because disease interacts with other factors. There's an environmental factor. There's something like crown rot. There's what's the hydraulic conductivity of the soil? How much stubble is there? What's the acidity of the soil? And it might happen to make a difference on that hydraulic conductivity. There's about 4 or 5 different things that go with it. The inoculum level is a very important factor. It should be measured and then can be looked at, looking at with the interactions of these other factors. So as the likes of data farming, those layers are there, and the analytics have been able to cross-reference it, we do need disease as a layer there that we can work with. So that's the barrier at the moment, I think, is growers and consultants looking 5 years ahead rather than just the here and now of what's going to make the most money for this year. It's building into the system, using it as a general health check for the sustainability, the long-term sustainability of the farming system. I think we need to have high levels of adoption and look further ahead.
So Rob, you actually bring up a great point there, and that is, and I'll get you all to touch on this, but none of you is actually utilising this technology in isolation from other technologies or data sets. It's all interrelated, and I was just wondering if you'd all like to share, some of it might be surveillance plus control, some of it might be about surveillance and different data levels, but you just touched on sort of nutrition, Rob. What are the other really important areas of technology and data collection that you think are critical to make your stuff sing?
I suppose if I just refer to our cotton project in southern New South Wales, we look at black root rots being a major yield roller in that part of the world. So clearly acidicity is one of the things. Other soil nutrition factors, certainly elevation, the proximity of where the low-lying areas are in soil. Other technology coming in could be canopy temperature sensors. So, and coupling that with climatic data, you can look at what are the triggers for when that disease starts to show up. Because in the pathogen triangle, environment is a very strong driver. So what are the environmental factors? How cold was it, and how many wet days was required to be able to trigger an inoculum level to generate a disease outcome.
How about you, Jaime? What are some of the interacting technologies that you guys are employing? It's not just about livestock ID for stock, is it?
Well, not necessarily. I think when we talk even just about livestock ID or tags, a lot of time you don't really think about what technology is in that piece of hardware. And so it's not actually the tag itself that's giving you information. There's different sensors in that particular tag. And so when we look at trying to predict the health of an animal or what that animal's doing, the two main forms of tech or information that we're getting is either that animal's behavioural activity, and that's typically going to be something that's like an accelerometer. So say it's that Fitbit that's telling you I'm walking, I'm active, and we've already established that in a number of different tag companies. Being able to use that little accelerometer to say that animal's standing stationary, is it grazing, is it ruminating? And then the other type of hardware or sensor or information we're getting is things like location. So whether it's GPS or a proximity type sensor, so where is that animal located? And we sort of need both of those information. We're looking at health and disease of an animal. I want to know what is it doing, how is it behaving, is it behaving abnormally? But then especially looking at disease or an outbreak of an exotic disease, I really need to know where that animal is. So behaviour and location are the two main things. We look at whether it's an endemic disease or whether it's exotic disease. Most of the time it comes down to what is that animal doing, what is its behaviour, and then ultimately where it's located.
Now there's a couple of things that I wanted to ask you about, Nancy, in this particular space. So firstly, sterile insect technology. Am I right that your technology, surveillance technology, is being used in conjunction with some of the SIP planning? Is that right?
Not yet.
Not yet, but obviously that would be good. So just for those of you who don't know, the South Australian government has invested more than $10 million into sterile insect technology for Q-fly or Queensland fruit fly. And essentially what they're doing is they're trying to reduce the population breeding. So, I mean, simple, but not really simple. Also, what about co-location with other services as well? I mean, Bioscout's doing some very interesting things. I know that you know Lewis Collins, the CEO, very well. What do you see as the really cool interconnecting things that can really take some of these services even further?
Yeah, great question. So we started, of course, with being able to detect fruit fly in real time. It's quite interesting just touching on what Jamie and Rob are talking about. One is the environmental conditions are always critical for pest and disease. So having that layer into the device, so our Gen 2 products are incorporating those types of sensors. But also, Jamie was touching on the animal behavior for livestock. Well, our technology came about by bringing biologists and engineers together. So engineers are, disciplined software, firmware, hardware engineers that don't like variation. Measurement is really important, or bridges fall down, or buildings collapse. Whereas biology, there's all this variability. Environmental factors affect it. So if we think about the micro scale of bringing technologies together, we started there at that very micro scale. Our sensors are novel sensors that basically based on the size, shape, and behavior of insects as they come into the device. So that's the biology component. That's where our magic happens. Of course, we think project into the future about pest and disease real-time monitoring, because the value of that to an end user, to be able to know where it's happening, to be able to respond quickly, and to be able to validate that their control is actually working or keeping them honest, so to speak. I think there's a super exciting future with that. At the moment, we started with fruit fly, we're adding different insect layers. Ultimately, our goal is to become like the BOM for insects, or BOP, Bureau of Pest Information. And with our sensors, you get this real-time data flow. So we're adding machine learning, so bringing in a different STEM into the picture to deliver forecasts for entire regions about pest forecasts that are very accurate, just because of bringing real-time data flow and machine learning together. So it's these different STEM disciplines that we're pulling in to solve some really big problems for ultimately more sustainable food production, more efficient pest and disease management.
Thanks, Nancy. So, Pete's still in here?
He most certainly is.
So while Pete's finding a couple of people to volunteer our first questions, or some comments perhaps from some of the other tech providers in the room, I just thought I'd give you a couple of stats. So in 2019-2020, plant industries represented a gross value of 30 billion in Australia. It's actually not dissimilar to the animal sector as well. And plant exports were worth more than 25 billion, mainly from grains, but also cotton and horticultural products. So obviously we are an exporting nation, and all of those products, as have already been mentioned around the example of the Australian Oilseeds Federation, must meet certain standards to show that they can actually have market access, and that is that they're free from pests and diseases. So it's critical, particularly for an ag region such as us, but it underpins everything we do. So have we got some questions, Pete?
Yes, we do. My name's Lewis Frost. Hi, Liz and the panel. There's a little bit of commentary around some legacy systems, some biosecurity systems we're working with today, and then we discussed a little bit about new technology, things we'd love to bring into those platforms. I guess probably kicking off with Jaime. Jaime, you talked a little bit about NLIS and a raft of kind of new technologies that could enhance it. But how do we go about bringing that technology into these legacy systems, not falling over whilst we're trying to do it?
Yeah, it's a perfect question. I think we need to actually ask the question of the end user of what do they actually want to get from these systems. And so whether it's a smart tag, and yes, all my examples today around exotic diseases and being able to detect, say, FMD, that's that tag sole purpose. There's not going to be any uptake if the producer has to pay all the money for that device. It's not going to work. So we really need to consider that whole supply chain and what information could we actually get from it. That next generation smart tag, NLIS, obviously for NLIS, very big, one of our probably greatest things for terms of biosecurity for livestock, but it's only compulsory for cattle. And so when we think about disease of livestock and FMD, which is also affected by other ruminant species, it's not compulsory in all states except Victoria for sheep to have that NLIS tag or our RFID tag. And so that next generation device can't just rely on our beef industry, it has to rely on all of our livestock sectors having to uptake it, but actually has to have some purpose or more information than just an RFID tag that's telling me this is animal 1, 2, 3. It has to actually give us more information. And all the work that we've done already with producers, we already know there's heaps of adoption issues and barriers to implementing this type of tech. And so we really need to work out what questions or what answers do our producers want to find out, or what issue are they trying to solve. And sort of, I guess, a bit of a pet peeve or a hype in this space is people think that the smart tag is going to solve all the issues on farm, and it's not the tag itself, it's being used as a data management tool. And you really need to understand what your problem is and what answer you want before you start looking into different technologies and how that's going to help solve your issue. So really the technology, that next generation tag, RFID or that analytic system would be the perfect avenue to go down, but that RFID tag needs to give us more information, so it needs to be coupled with other technology in terms of location, what is that animal doing, and actual outcomes in terms of alerts or algorithms for a variety of issues. And then if it could also touch on some biosecurity stuff, that's also going to have other end user, federal, national significance as well as an added bonus that's not just for that producer as well.
Hi, April Kavanagh. A question, I guess, with probably more hyper-aware around pandemics than ever before. So I guess if we were to have a COVID-19 equivalent event in ag, what would that look like? How ready are we for that? And I guess also interested in your insights, you know, are we more ready as a result of COVID, or are we still just sitting back, especially, you know, having swine flu and all that sort of stuff just on our doorstep most recently?
So I might touch on this to start with, and what you just asked is one massive question, just saying, April. So one of the gigs I do on the side, I'm a director of Plant Health Australia, and in Australia we're very fortunate and one of the only countries in the world, New Zealand is one, Canada's getting there, but after citrus canker occurred in emeralds back in the 2000s, they actually set up a couple of things. So one is that there are two entities, Plant Health Australia and Animal Health Australia, who are two organisations that have memberships from each state government jurisdiction as well as the Australian government, but then also industry members. So Animal Health Australia obviously has all of the livestock guys, Plant Health Australia has the industry members such as, Pop Australia, those types of entities. So one, there's actually a framework for sharing information, and the second thing that was set up, which is very much around that preparing for disasters, which maybe we haven't seen. Well, I mean, really, COVID has demonstrated how the system works already for biosecurity for pests and diseases for animals and plants. So for both those industries, they have what's called a deed, and as part of that deed, they actually identify what the national plant pests and animal pests are, and they have a set arrangements as to if there's an incursion, who are the industries that are affected that need to be at the table, and cost sharing for actually, managing incursion and hopefully eradication. So, maybe in some respects, ag's ahead here, but it's not easy, and no one has a lot of resources, and it's very challenging. I don't know if anyone else would like to add to that. It's a reasonably technical question, so I hope I've done it justice.
One thing we do have generally is a level of professional people out in the paddocks regularly. So we have a good monitoring system, and there was a particular episode at the Sydney University farm at Narrabri where there was an alert from one of the researchers indicating they thought that they saw a strange disease in the plant that could have been carnal, and it was shown to the authorities, and it made us absolutely and patently aware of the risks that we run, because it's a facility that had international visitors coming and going, and if it was a positive identification, it was a serious incursion and had the potential to shut down the grains industry in the eastern seaboard. I mean, it was high alert. As it turned out, it was common, but it had to take some positive identification. But the good thing about that was we have professional people and there are trained consultants who are walking through our fields and looking for things that look at normal. So, in some ways, certainly UGen 99, the stem rust incursion from a grains point of view would also be potentially disastrous. So we've just got to be alert all the time.
Any more questions? Yes.
So, Christine Rolfe again. It's really more a comment about the biosecurity in the animal world. On a cruise, and it is a few years ago now, but we, Northern Australia, from Darwin around to the West Australian coast, we actually went on land in Timor, which is an island of Timor. There was no footpath or anything else when we got back on the ship. And to walk back into Australian waters and hop off of land in Australia, and that, to me, that was just one of the biggest biosecurity risks that I've ever seen. So it's not just us here on the land, we have to be so concerned about all sorts of things that are happening on our coastline.
And it's really interesting here because, resources are finite. It doesn't matter what industry you're in or, what organisation. And there's extensive modelling done by the Department of Agriculture on where incursions and pests are showing up at the border, and actually use that information then to try and direct resources as well as possible. So you might have heard there's been quite some activity around brown mum-rated stick bug coming in containers. There's quite an interesting project now at the Port of Brisbane where they're using X-ray. They're taking multiple angles of photos of everything coming in the space of about 4 seconds, trying to do some of that early detection. But hopefully technology is a place where our dollar can help the efforts go further. I wanted just to, Pete, if you don't mind, or would you like that person to ask their question? And I wanted to actually pose something to Jossie and Andrew.
I don't want Melissa to forget her question this time. There's an enormous amount of pressure building up. Get it out.
The next gen of the ear tags, when's that expected?
Yeah, well, I hand over to Sarah.
Yeah, I'd love the microphone over there. I mean, I'm only here to help.
I don't think we have an answer to that. If you look at the history of smart tags, it was only 30, 40 years ago, where if you look at some of the history of this technology, that the first smart tag pretty much was a giant battery with an antenna as a backpack on the back of a cow, and that was in the 80s. And so even though it might not look like from the outside that we're making a heap of progress with this kind of technology, we have come a long way in terms of where we started, or when we used to shepherd animals that had a bell, and I could hear the bell, they must be close by. And so we are making progress. There's still some big questions that we need to ask, or as a producer, I would want to be asking any of these companies, how much does it cost? What is the tag retention rate? There's lots of other things that we need to consider. And also, animals are hard. We make a joke within our team that if you gave a soldier a gun, they're going to look after it. If you give it to a cow, they're out there to destroy it. And so just because you spend several $100s on that piece of hardware, it looks nice and pretty, and I'm really happy to buy it. Unfortunately, our animals don't have the same attitude. I'm going to keep that in my ear or keep it around my neck. And so there's lots of environmental challenges, connectivity challenges with all of this. But it's nice to see there's a lot more options coming out, and also other options for other industries like our sheep and other industry as well.
What sort of process that you're going through? And you're saying there's a lot of questions to the end. Do you have a forum for those types of questions to be asked so that
So I guess I have a bit of a unique perspective. Being a researcher, I can be quite independent in terms of assessment of this type of technology. For me personally, it's more I work with certain funding bodies to ask certain questions. So a project we've got at the moment with AWI is they're really keen to look at predation and health detection of sheep, and we're working to create actual algorithms to be able to use that technology for that. But for each individual company, they've got different objectives. Several other tag companies partner, whether it's with the university or directly with producers, where they're doing their own external research or research in-house. That's completely up to them, and also completely up to them whether they share that information. And so some of that information won't be freely available or won't be common knowledge in terms of whether it's tag retention rate or things like that. It really depends. We've got individual companies that they're businesses, so it's their intellectual property and up to them how they do their own research and ask some of those questions. But I hope that most are at least thinking about what are some of those main objectives that producers need to answer and how can that tag help. But it's perfect questions what I would be asking directly to any smart tag company.
Just really quickly, the comment I'll make is traditionally we saw advanced technologies being developed and designed and being brought to the market completely on their own and isolated from such programs like NIS as a really good example. I think probably what's great to see now is we're seeing technologies tailor-made and designed to plug into legacy systems. So technology is not just coming out to be disruptive for disruption's sake. We're able to, with advanced technology, build in a level of backwards compatibility, which hopefully sees more advanced technology being used in these legacy systems.
There's a follow-on from that. I can see that a lot of the technologies that are being introduced set challenges for our professionals, for consultants and key growers. They can establish their own case studies. They could really start to set up their own mini research projects on their own farms, rather than sit back and rely on the research bodies to have to do the work. There's no one better than themselves to be able to take these projects on. There are mechanisms there for monitoring, and there are mechanisms now for management. So you do it yourself. Start with a group of other growers or a group of other advisors. Start to get your heads together and devise these case studies, because there are now the options there to be able to really analyse it and make meaningful results of it, and make material and monetary gains from it. So that's the challenge. That's the challenge I put to the audience here.
So the last question I'm actually going to pose to the panel is, if you got given a great big bucket of money, what would you use it for? That is directed towards their business, of course. But one of the things that I'm really excited about the future of is automation. And while there's an enormous amount of work going on in automation, particularly around labour saving, like picking and those sorts of things, harvesting, I'm quite excited about the potential for, in the future, not right now, but the future where those cameras are actually collecting all sorts of data. And I just wanted Andrew to make a comment, because obviously people know of the work that Andrew and Jossie are doing in the broadacre space very well, but they're also doing quite a lot of work in the horticulture sector. But if you want to make a comment about how far off you think that sort of technology is, using machine learning and sensing.
Yeah, and I'll start off with the difference between automation and then autonomy and robotics. I guess for me, automation is taking an existing process or some sort of technique and using a robot or a machine to automate it. So you're doing the same thing, you're just taking things out of it. The bit I get excited about is robotics and autonomy, when you start actually looking at kind of different systems or different ways to do things. So not actually just automating something, but actually looking completely at the end product or the end game we want to do. But some of the things that we've done have been interesting, that they not to talk about today out there in the field, was in orchards where put cameras on board robots, to look at the flowering, to monitor flowering in apple orchards and look at each individual tree. And with using machine learning and computer vision, we can actually pick each tree at what stage of flowering it is. So apple trees put on too many flowers. If all those flowers go through, you end up with too many apples and little small tiny apples. So farmers actually thin their flowers to remove a lot of them, so they end up with good quality large apples. And the technology that we developed looks at each tree, says this tree is now 80% of king bloom, or it's 20% of king bloom, and it's multiple stages in apple flowering. And we're able to then go and interact with that crop, and we go and just thin the trees on the days they need to be thinned. Whereas industry best practice at the moment is spray and pray. You go into a whole block, say this is the day to spray, you spray the whole block, knock all the flowers off, and potentially 20% of those trees it was too early, 20% was too late, and the rest is somewhere in the middle. And I guess the bit that exciting about that is it is actually an automation of thinning. It's actually autonomous farming in a better way. And I mentioned it earlier as well. Is that we can do so much with data and insight and machine learning and data analytics and remote monitoring and all these sorts of things, and sensors and IoT. But there's a huge opportunity out there to start interacting with crops, and they're the things we haven't done, and that's just starting to open up with robotics, and that's the new farming systems. That's something like RapidAim picks up a pest incursion. That's a robot going out and actually doing something different in the field, and it could be applying a biological product that hasn't been viable today. All of a sudden becomes viable, but it's applied every 6 hours through the night when there's no UV light, and all of a sudden that biological product's gone from being on the lab bench because it was never considered practical to put out during the day and no one used it. All of a sudden we can actually use this to solve a pest incursion. So there's this kind of loop coming behind all this IoT and remote sensing and data analytics and all these things that we're going to feed into biosecurity and farming systems that I'm pretty excited about.
Yeah, okay, so talking about excited, brief response from all of our panelists. Rob, big bucket of money.
Well, I see DNA as being a vastly underutilised resource in agriculture. It's reliable, clearly, through the question of COVID, we've learned to rely on PCR and DNA highly. So it's reliable, it's repeatable, and it's scalable. So you can measure a lot of things reliably, quickly, in big numbers. That opens up all sorts of opportunities. If we go really big blue sky way out there, we can measure the biome of the gut, which of the human stomach, and so that's the biological makeup, and what quantifies a healthy gut. There's research work being done on that. We're always talking about healthy soils. What defines a healthy soil? We can measure the physical, the clay content. We can measure the chemical, as in the nutritional makeup. We are very, very poor at understanding the biological. I see DNA as being the answer to that. And I would challenge the GADC, the CHDC, the CHDC, all to investigate what constitutes a healthy or resilient soil and what's the chemical, physical, and biological makeup of that, and can we manipulate? Can we turn an unhealthy soil into a healthy soil by introducing or manipulating the biology of it? That's my challenge.
Yeah, that's awesome. How about you, Jaime? Big bucket of money.
So we touched on a heap of the applications of this smart tag technology, but what's really currently missing is an actual economic analysis of those costs and benefits. So we don't have any tangible values that we can currently give a producer that if you spend X, Y, Z on the smart tag, you're actually going to save this much money in labour, this much money in animal welfare outcomes, and early detection of health and disease. And so for this technology to address some of these adoption issues, really be used widespread across all of our livestock industries, we really need to actually understand some of those costs and benefits, monetary, social, etc.
very altruistic, Jamie. Nancy?
Mine's not as altruistic. So I guess first of all, I'm a strong believer that Australia has to be a technology maker, not taker. You've seen some great examples of that today. It's a space where we think about growing, agriculture to 100 billion. A big part of that, we know AgTech is going to play a part, but it shouldn't just be an enabler to produce more food or more sustainable food. We actually have an opportunity to create our own industries in technology. And so step one with that money would be, we should be making sensor technology as infrastructure to export to the world, but we should be exporting to the world the SaaS service in terms of pest and disease surveillance and forecasts. So I would like to use that money to grow an exciting industry that basically, absolutely, we're already on the map with our agriculture. Australia is already ahead of the pack with agriculture. We need to capitalize more on that and believe that we have the best, well, we know we have it, but actually use that money to grow some exciting industries.
Great. I think that's, do you have more, we still have time, Pete?
Renee Anderson, my question is for Dr. Nancy and for Rob. An area that we identified as a gap in our industry during the pandemic was in workforce and development and training, specifically in agronomy. We have a massive shortage, so we've got lots of next gen going into bug checking. And so we saw a really large increase in the misidentification of insects, weeds and diseases. I'm just wondering where you think there's a role to play with technology in education, extension and identification.
Yeah, great question. So there are some other companies that I think Go Micro is one, where they actually have a simple solution of snapping it gives studio quality lighting on an iPhone phone to take pictures of pests and disease. It's a great example where that could be an enabler of helping train people in the field, boots on the ground. So I think that's one space, and it's a really accessible space. I think the technology like ours, because it's so scalable and you can roll them out across large areas, early alerts and forecasting for very specific groups of pests that basically cause the most pain for industries, the most money is spent on controlling them. That's really our sweet spot. But that would be there are other technologies out there that I think can just quickly upskill people because of the easy way to both take a picture of something and that AI that can help with ID can get that immediate feedback loop.
See, there's still work to be done within grower solution groups where just improving the efficiency of the outcome. So rather than just having a process being trained to on one-on-one, being able to have it to the head to be able to then train 50 people underneath it. So you're more localised grower solution groups and groups of farmers getting together and sharing information, I think, is required because there's just the whole, there's growing page of no hear from elders and other resellers, there's a shortage here. There's a shortage of skills.
I think too, it's possibly worth noting here that, tools can never take the place of agronomists, pathologists, entomologists, and those science leaders in our community. And one of the things that we've certainly grappled with at Plant Health Australia, and I know the state and federal government has as well, is that, with Twitter and Facebook and all those sorts of things, you can post a picture and someone, can make an assessment of what they think it is. But if that pest is actually misidentified, you can actually lose an export industry overnight. So, it's a challenge and you certainly need the people and the capability.
Fiona Lake. Yes, if I had big bucket of money, I would rebuild the biosecurity lab back in Townsville. I would cut the Queensland government into it.
So one of you should have thought of that, sorry, I had to put that 2 boxes in, although I imagine you might want it in emerald. My question is a little bit down in the weeds compared to what we've moved on to. It's about thermal cameras. Because I fly drones and the improvement in thermal cameras is huge. You mentioned X-ray. I just see huge potential with thermal cameras getting more and more accurate. I mean, China was using them for quite a long time, like 3 years ago, in airports to assess people for disease. And I know feedlots in the US, for example, have been trialling them in feedlots to assess animal health early. So, Jane, particularly, I'm wondering whether you came across thermal cameras and the uses in your
Yes.
research.
So it's probably still more of a research tool than something that is commercialised yet, but they have been using more pest identification, commercial properties, dingoes, dogs, foxes is one example. The feedlot example is perfectly correct as well, and even things like mastitis, so the health conditions of animals. So it really just depends on where that camera goes. They're quite easy to implement in a more intensive system, so we put it, especially for our livestock industries, where leave that camera stationary and that animal's passing through becomes a little bit more difficult in that very big extensive systems. Yes, we start touching things to drones and that, but at the moment it's probably more relevant to some of those intensive industries that are expensive ones.
And certainly, Fiona, I would say wait another 6 months. I think there'll be quite a bit more coming out onto the market, new products using that sort of technology. Pete, I think we're done, aren't we?
Yeah, pretty much done.
Yeah.
Yeah.
Could I just add one last one?
I did get a couple of questions from people out in the ether.
Yeah.
On Christine's question, they were intrigued as to know what a cruise ship was.
Wasn't that long ago?
Big ship, people used to go away to much cheaper places and have fun.
So just before we wrap up, I would be amiss if I didn't say that the best chance of containment of any biosecurity incursion is early reporting. If you see something unusual on your property, yes, tell your agronomist or your local DAP, but importantly, report it. The Exotic Plant Pest Hotline, 1800 084 881, and the Emergency Animal Disease Watch Hotline for sick livestock and aquatics and poultry. It's up to all of us, biosecurity.
Big thanks to all our panel, everyone. Thanks for sharing your work. And a big thanks to you too, Liz.